I'm Grishma from Group 471 working on the project Database Guard. Our project is based upon a paper RC rank, which basically ranks the root causes for a slow query. So in this paper, it proposes a method that is capable to identify both the possible root causes that are for slow queries and ranks them according to the potential for accelerating the slow queries. Coming to the dataset description, we're using TPC-H dataset, which was developed by tpc.org. In here, we have 9 features. The first one being index X, which is a simple row index identifier, and then query, which is the actual SQL query, and plan JSON, which is the execution plan of the query, which is in JSON format. It basically describes how the database plans to execute the SQL query. And then we have log all, which is a list of all the log level statistics gathered during the execution of a particular query. And then we have time series, which implies the performance or the KPI metrics collected over time, such as CPU usage, memory, and these are stored in a time series format. And then we have multi-label, which is a binary list that indicates all the possible root causes applying to this query. And then we have opt label rate, which is possibly the labels or the change in impact rates for it. And then the duration, which is the actual runtime duration of a particular query, which is given in seconds or milliseconds. Then we have temp, which seems like a concatenation of index X and the query. This will be useful for debugging and to easily trace back the query. Then these are all the types of root causes that we have. We have 9 root causes such as bad join order, missing index, and a few more. So this is basically how we represent our root causes as a list. And for example, let's take this. There are in index 4 and 5, we have ones. That means that a query is having these particular root causes. When it is 0, it does imply that these root causes are not affecting our particular query. So in this example, the root causes are statistics and index issue, because the 4th and 5th indexes are marked with 1. And then this is our input. Basically, for training our model, we have all the 9 features that you have seen before in our data set, and those are our keys. And then we have the values that we got from our data set, and some of them are processed. This is the model that we are using. So this is a multi-model root cause diagnosis model. So we have 3 layers in it. So first one being the input embedding module, as we are taking 4 different input features such as SQL and the plan, which is the execution plan of a query, then logs and the KPIs. All these 4 features or the inputs will be given to different encoders and will be obtaining our embeddings. And all these embeddings will be passed to 2 different transformers. One is the common cross model transformer, where all the embeddings are passed, and also we have this adaptive cross model transformer. Along with the embeddings, we're also passing the root cause gating units and doing a dot product on the gating unit result and also the embeddings. And from that, we have the adaptive cross model transformer, and we'll be taking the outputs of both common cross model transformer and adaptive cross model transformer, and will be giving that to our root cause estimation module. And in here will be the root cause score regression is done, so that every root cause is given a rank. And this is how the output of a training looks like. So these are all the 9 root causes that we have. These are the rankings of a few samples and the predictions. These are the actual rankings, and these are the predictions of those samples. And we got an accuracy of 67% for this particular model. And then we've also worked on MySQL, Prometheus, and Grafana. So this basically starts in MySQL. Whenever we execute a query, the internal counters of MySQL database get updated. So from these counters, we'll be giving them to SQL exporter via TCP protocol. It pulls all the counters from MySQL at regular intervals. And this SQL exporter is connected to Prometheus. Prometheus, it pulls the metrics from exporter regularly, and we have done it for 15 seconds. And that is done through a HTTP protocol. And from Prometheus, the details are being sent to Grafana, which is the GUI that we can see over here, which is done through HTTP protocol. And the Grafana shows us all the type of metrics, such as the number of connections that we have, how much memory, CPU are being used. So there are different sort of metrics like that in Grafana. We have established a client server communication. So basically this shows the number of clients that are connected till now to a SQL server, and it also shows us the client query distribution, the number of slow versus fast queries, and the query activity with respect to time. So, and this is the activity logs, as we can see on the right side. We can see which client has executed those, and the type of the query, and the actual query that has been executed, and here we have the result of the query. So all these are done with the client server communication. Here we have monitoring the packets through Wireshark. So Wireshark is basically a platform which monitors the network packets. So here, as we can see, we are monitoring the port 50 TCP 5050. This is a where our client and server are communicating. As we can see here, we have a packet. Let's see this with a violet color highlight. So this is a packet, and we have our source address and the destination address, and the packet is transmitted via TCP protocol in here. And we can also see the data bits that are being transcribed, that are being sent over here, but this data is encrypted. We can actually encrypt or decrypt the packets. So here it is done basically like this. So we initially generate a key for both the server and the client, and that is done through ECDH, that is a protocol where both the client and server has a shared secret. And then the key derivation is generated. So basically in the initial key exchange, they'll be deciding upon which kind of key they should use, and then based upon that they'll be generating an actual secret key. And then the encryption is done. Whatever the data packets that are being sent over the network, that will be sent with those cipher enabled. So generally we have the AEAD cipher, and all these data packets are encrypted at the sender side, and then will be only decrypted at the receiver side. So this is basically how the encryption is done. As you've seen on the previous slide on Wireshark, all the encrypted data, we can actually decrypt a package, and we are currently working on that. Thank you.